So let's go. I have a lot of material to present. I hope to fit inside the, allotted time slot. My name is Mark Novak. I work in applied research in JP Morgan's Future Lab for Applied Research and Engineering. We're a small outfit that basically looks into emerging technologies and how to bring these technologies into the bank. I'm very, very excited to be here today and to share the stage with so many amazing speakers, including some of my former colleagues, such as Mark Rusinovich, and some future people who'll be presenting today. My interest in confidential computing goes back to about 2007, when I first looked at TPMs, and I looked at it and said, the next evolution of this technology will allow you to run code securely on machines you don't own and have your physical possession, and dethrone administrators. And at the time, people like even Microsoft architects looked at me like I was unwell, and yet here we are. So in today's talk, it's kind of intended as the starting point of a conversation. Don't look at it as a set of stone tablets that some architect brought down from the mountain. I will probably be wrong in many places, and that's perfectly fine. I believe that we all grow and find truth through dialogue. So let the bad ideas die and the best ideas win. And I already know that my talk will overlap with some of the things that were already discussed. So I think we have a lot of ground to cover. So in today's talk, I am going to go over some cases why a large financial institution cares about confidential computing and the governance goals. I will then illustrate sort of the approach that I am talking about through walking you through a hypothetical application that we would take from its current state to a confidential state. I will leave room for Q&A. I will not be looking at questions that are posted throughout the talk. And if I run out of time, then I will take the extended Q&A session. All right. So there is, I just posted on my LinkedIn profile, and there is also on the OC3.dev website a companion paper that basically taxonomizes everything and is a lot more dry than this talk. And I will set up a North Star for the comprehensive governance. And then I just want to emphasize that North Star is something we approach confidentially, asymptotically and gradually. And then I will sort of, in the paper, I propose a whole actually reusable and pluggable governance mechanisms for the industry. So we'll talk about some of that today. All right, so why would a large financial institution care about confidential computing? So I've now worked on both sides of this fence. I've spent about 23 years at Microsoft, most recently as the architect of some of the Microsoft confidential services before I left in 2018, just to try something else. All my interns were born up to my start date. That was the reason for leaving. And, as someone who's now worked on both sides of the fence, I can tell you that in all cases, confidential computing serves both customers and providers of cloud services. Customers don't want the providers to access their data, especially when you operate in interesting environments with maybe extrajudicial overreach. Providers definitely don't want the bad reputation or the reputational hits, financial hits of accidentally having access to customers' data. So we're sort of serving all users here, all parties. So protection of data in use is relatively new on the cloud computing scene, as you all know. As one of the large financial institutions, we have a lot of data. We process trillions of dollars of transactions a day. A lot of these data are highly sensitive, and simultaneously not all the useful data belongs to us. So traditional multi-party computation comes with a higher latency communication overhead. Fully homomorphic encryption can be slow, not general purpose. Confidential computing is attractive in part because it promises to be the fastest of the bunch, as well as the only truly general purpose computing solution. So, and some of the data are just so sensitive that human eyes should just not be looking at it. So if people are uploading images, even profile pictures, like, we don't want humans looking at it because, you never know what you find. So, you really want to know the guarantee that no human eyes will ever touch some of the content in some cases. So now the other thing is not just data, but algorithms themselves are sometimes confidential. And sometimes the algorithm may be even more sensitive than the data that is fed to it. So outside of the cloud context, confidential computing traces some of its roots to gaming console design, where a general purpose computing device is manufactured at scale, placed in hostile environments. And there is a high degree of similarity between that and devices such as ATMs or IoT gadgets, both of which big banks may operate a lot of and manage remotely. Now, the most important thing is that every time a new kind of protection is enabled by a new technology, it eventually becomes part of regulations that institutions must comply with. And let me assure you, the bank's regulators have real teeth. This has happened with protections of data at rest, then data in transit. That's only a matter of time with similar regulations will apply to data in use. And so as a heavily regulated institution, we need to prepare for this, as it is absolutely certain to come. So let's go over some basics. There are several areas that fit under the domain of governance listed in a not very accurate Venn diagram that you're about to see. And anyone who has worked in the space knows full well that you can meet all your security goals and only some of your compliance goals, and vice versa. A more holistic view of the problem space would also include resilience costs, because neither security nor compliance achieve those goals on their own, and confidential computing may impact them all. So let's go into some examples. So cipher strength. If you roll out quantum-resistant crypto, you will improve security. You will do little for reliability. It is not going to be required by compliance, at least not yet, and it may affect costs. Patch frequency is the weirdest thing you see at a bank. So, it's not strictly speaking a security requirement how frequently you patch, but compliance will say, for instance, for us, you can not have any vulnerabilities unpatched that are longer than 14 days. You can fix that a couple of times. You can say, well, I can roll out updates, or I can simply repave everything every 2 weeks, which is, you see that actually very frequently, just because it's easier than rolling out updates with the latest version. Now, security people will tell you that although you're, in either case, you're compliant, it's not a good idea to have a high security vulnerability sitting around unpatched for 2 weeks. Reliably rolling out a security update without causing downtime or allow for unapproved rollbacks. Now, then the question in terms of governance is, how do you achieve that, and how do you prove it? And also, last but not least, is how much extra would your confidential computing cost, especially in the interim where we do not have secure hardware acceleration of storage or network or IML. Are these costs acceptable? I can tell you they're not acceptable, because you get 20, 40 times slowdown if you don't offload. And how do these costs compare, and where do they spike? So ultimately, what this talks about, you can only achieve a goal if you can measure and assess your current state and your progress towards that goal. So that's going to actually be the overarching theme of the talk, although I will step very, very heavily outside of that boundary. But you can see that as a leitmotif across everything. You need to also always measure and assess your current state and your progress towards goals. All right, so confidential computing governance. So what are the confidential computing governance goals in the public cloud? For one, the confidential computing model is different from your traditional cloud model, which is verify first and trust later. And the traditional trust but verify model that you see in the public cloud today does not apply. Confidential computing presupposes a much higher degree of supervision by the code and data owner over the deployed applications, because otherwise it's pointless, right? If you do not have continuous adherence will need ongoing supervision, including during upgrades. Now, the reality check is your developers will want to continue using the existing CI/CD and orchestration products and tools, but as we shall see, lift and shift is not possible, and new approaches are required in many places. So what we will need to do is establish new patterns, because my employer has some on the order of 2,700 applications, and if all of them solve their governance goals in their own way, basically what you get is an intractable mess. All right, so governance computing goals. More formally, we're going to look into satisfying all of the following. So a large institution will need to do this repeatably across the entire application fleet, which can be very, very large. So piecemeal bespoke solutions will not work. So we are looking, and you can read from the slide, but you can see how the notion of provability comes up again and again and again. So we're looking about guaranteeing compliance to policy. We are looking at basically proving that if you are putting something in production that's new, that it's actually there and can be done timely and it can be done correctly. Then we're looking at accurate reporting of everything, that we need to identify bad actors. So report across everything. And I've seen a lot of fantastic ideas in everything that was discussed so far today, but very little attention was actually paid so far to how do I know when I'm sitting in my, security operations center, that what's going on in the cloud is actually, conformant to policies, and who are the perpetrators, and how do we identify and correct things very, very quickly. So how do we make an application governable? Confidential computing at its core, and everyone understands that by now, is a rethinking of what is in the TCB of a deployed application, and it's a radical rethinking. So attestation service is one of the most fundamental roots of trust for any confidential application, and the other would be trust in hardware manufacturers, and the third one is the trust in your hardware security modules and your key stores. The trust in the attestation service must be absolute, and this is actually the point I raised with Simon Frost of Verizon a few weeks ago. You cannot have a confidential application where the cloud provider is in the TCB of the attestation service. Now, the attestation service is unlike other confidential applications because it is, if it's operated by a public cloud provider, then you need to establish trust in it itself, and that requires attestation. I would call that the bottom turtle problem. Another possibility is operating it on-premise. Yet another option would be operating it like some customers operate HSMs in public data centers, by having their own hardware in a physical cage with very strict ceremonies around access provisioning and operation. Until further notice, the cloud control plane is not to be trusted, and neither is the cloud identity and access management stack. Yet another thing I haven't actually heard mentioned today, because whoever can decide who has what privileges in your application may end up gaining full control over your application. And this aspect of cloud deployments has not yet been fully understood, and we'll begin to scratch some of its surface here. And what is conspicuously missing from this diagram are the supporting services, so other confidential cloud services that the application may interact with or depend on for its capabilities. Not all services are supporting services, so if you're in AWS, I don't envision that S3 becomes a confidential service, but other services might. Maybe there are other applications that you wrote. So the trust in supporting services is established using the attestation service, so it is safe to omit from this picture. And the auditing backbone cannot be per application, as that would be a recipe for disaster. We need a reusable, ideally multi-cloud solution satisfying a cornucopia of security and availability requirements. All right. So I pulled this cartoon from an old New Yorker article where, the good news is you're not paranoid, and the bad news, everyone's out to get you, or it's all joke. But here's the thing. If you're going to make money out of confidential computing, the paranoid probably are not your market. The regulated are your market. And the regulated markets will need confidential computing. So for the rest of the talk, I will sound very paranoid indeed on behalf of all the regulated customers. And this stock will set up, this is, I want to make it very, very clear. The stock sets up the North Star. We do not need for everything to fall into place right away. We will be happy with asymptotic convergence. I will, rattle off my paper has 30 pages of different requirements. Don't let that stop you. We can get there in incremental steps. So let's now framed it completely. Now let's talk about, what the governance puzzle looks like. Well, there are a total of 5 different component classes to governance, and each represents a pretty large domain. So code is not just your application code, it's the entirety of all code that must be trusted, from the compiler and open source libraries to platform hardware to code behind supporting services. The weakest links, as you know, are the ones that get attacked first. And to be sure, this category does not include the untrusted control plane and anything outside of the confidential computing TCB. Configuration is something that is directly read by the code and directly influences what the code does. And I keep repeating this mantra: bad configuration can make good code do bad things. And that has direct impact on how you attest the workloads you run, because you need to attest them together with the configuration, and the configuration itself is often confidential. Policies. It's a combination of code and data that are extrinsic to the code and includes controls. So in the controls domain, if you work for a bank, there's a whole theory about it. There are preventive controls, detective controls, corrective, inline, and compensating. And again, more information on that in my paper. But the important thing is policies are completely outside of your code and yet have very, very direct control over your code. And because of that, if you have bad policies, you'll have bad governance. You need to govern your policies. And in some cases, policies themselves must trust confidentially. So again, something that we need to start thinking about as an industry. Ceremonies. Now, machines cannot and do not know right from wrong. right? As you will see plenty in episodes of Black Mirror. So processes and protocols involving human beings invoked when creating, evaluating, and deploying code configuration and policies, as well as dealing with reports and outcomes. And ceremonies are also behind all sorts of interventions, such as break glass, and ultimately the humans behind the ceremonies are ultimately held accountable for mistakes and misbehaviors, and governance is impossible without humans performing these tasks and being accountable for these tasks. And finally, enforcers, this is what makes governance have teeth, right? They are the outside parties and mechanisms that individually and collectively ensure that parties to contracts can be compelled to adhere to their terms. These are warrants, courts, governments, arbitrators, regulators, and everything in between. All right, so governance at a glance. There are probably a big part of it is going to be reliance on open source code libraries. This is where a lot of your repeatability is going to come from. Then your developers are going to go write a bunch of code and add some configuration. All of that goes into the CI/CD pipeline. I mean, you guys know all the stuff. I'm just putting it here for context. The output of the CI/CD pipeline will trigger some orchestration actions, which will result in the deployed or redeployed application, which then works with supporting services. And policies and controls oversee basically all of these components, right? All of these components need to create audits of everything that they do, and these audits need to be, queryable, collatable, lossless, and so on and so forth. The audits is what will be used by ceremonies and enforcers to basically influence policies and controls, also do break glass scenarios and go find the responsible people. So there was a lot of content today already on things like how do you create like repeatable binaries and whatnot. So there is again, I'm sort of just framing what's going to happen. And now let's actually put this in a relatable content, because it was a lot of theory. But let's say that we have this application, and this is my hypothetical high frequency trading application. And in the hypothetical high frequency trading application that we might want to put in a public cloud, the trader controls trading parameters by submitting commands to the command and control service. The command and control service will update compute and update trading strategies inside the actual high frequency trading service. The high frequency trading service will take in market information that is stored in some database by the ingestion service. The ingestion service in turn will take information from market feeds and the HFT service will then submit trade requests, which are now public, to the external order execution service. So this is my hypothetical application. And let's see, what are we seeking to keep confidential? The trading parameters and strategies, super secret stuff. What they are, how they change, all of that is confidential. The high-frequency trading algorithms themselves, this is one instance of where the code is more sensitive than the data. And so what inputs does it use? You probably shouldn't be able to find out. What kind of internal processing it does, you shouldn't be able to find out. You can't hide the trades that you place, because I mean that's all public information. That's a good thing. The market data that is ingested needs to be safe from tampering, from disclosure, also from rollback, because if you operate on stale data, you're going to make bad trades. All right, so what are the functional requirements? We'll need super high availability, because during trading hours, the more trades you perform, the more money you make. You need to be able to, oops, sorry again, I need to go back. You need to be able to roll availability, like updates in all times, while preserving high availability of all bespoke services. You need to ensure high performance. That often means being able to auto scale to handle the load. And throughout of it, you will need full attribution, because again, if there is misbehavior, we need to be able to find out where it was caused and who to hold accountable. All right, the ingestion service, that's the simplest one of the bunch. The ticker services must be authenticated, but ultimately they represent public data. The output market data must be timber rollback evident to be properly authenticated. It also must be encrypted at application layer, because if I'm putting something in a system such as S3 or like anything else, and if the encryption at rest is managed by keys that I do not fully control, then it's probably not a secure solution for confidential inputs. And also, encrypted data is never rollback safe. All right, so input signing verification can be baked in or read from configuration. Output signing and encryption keys must be provisioned contingent on attestation, because again, you cannot put these keys in the wrong hands. And you also have to be cognizant of the fact that you need to rotate all keys at any point in time in case of some sort of a security update or key compromise. And then traffic shaping will take place during a rolling update. And turns out that a lot of dealing with traffic today happens at L7. So this is where you start paying like close attention. So let's talk about key provisioning. So the main difference between the regular and confidential orchestration systems would be key provisioning and code update handling. So under regular key provisioning system, your orchestrator will procure the keys. It will place them on a volume in plain text, which is something I've been screaming about for a really long time. And then we'll start the compute instances. And the compute instances will mount the volumes, will read these plain text keys, and will dismount the volume. So it's convenient in the same way as HTTP was more convenient than HTTPS, but it's not good. So under confidential computing, we now have this compute instance that first needs to talk to the attestation service, which basically gives it credentials per some policy. And again, whenever I say policy, I'm apply governance. And then it needs to go to some key store with that policy, with its own policy, present some credentials, get some keys. And under the verified and trust model, you can no longer place plain text keys on plain text volumes. So the workload must procure its own keys with the help of these services. And you basically need to start treating the orchestrator as the dumb pipe for TLS traffic. And the orchestration framework is this dumb pipe for cryptographic keys destined for confidential compute instances. So the orchestrator will start the instance, and then the instance will do, contact attestation service with credentials. Now, notice that auto scaling, this is not going to work, because the moment you introduce a network traffic or to and from different services, every time you need to start a compute instance, you are now introducing fragility, and you're introducing potential for downtime. And that's why I'm saying this may not scale. We'll need some sort of optimizations, probably some sort of like local attestation. Now let's talk about rolling updates. That's another really hairy subject, because under the rolling update, you will have a traffic proxy of some sort that will start up a bunch of instances under the new version, and it'll gradually send traffic over to them. And some entity must be in charge of updating attestation policy that's phasing in V2, phasing out V1. So let's take a look at what the orchestrator will do today. It will launch the instances, gradually traffic instance, and then each instance can share keys from the same mountable volume. So very convenient, not very secure. You don't have to update the policy. Under confidential computing, we're now looking at, we need to gradually govern an attestation service policy change, because at some point only V1 is, or VN, whatever you want to call it, is legit. Then it's V1 plus V2, and then you have to phase out V1 to allow also V2. But as you know, every production bug ever found has passed all internal tests. Sometimes you have to deploy like 10,000 instances before you notice misbehavior. And this means that although in confidential computing, we really do not like downgrades, during this type of upgrade, we need to allow them by design, because we, in fact, may have, roll out a problem. So another consideration there is when you roll out updates, you may need new keys. And this means change to key access policy. And this means that we need to govern that very carefully. So the traffic proxy will have to adapt. There is, especially because it operates at L7 and has visibility into your traffic, we'll need to do some things there. Okay. So The next one is if you deploy a cloud application today, you will probably end up using the web application firewall and an application load balancer given to you by your cloud provider, which is, again, operates at L7, does traffic inspection, so has to be treated with extreme care when confidential commands go through. So today, that's what happens. You start up the thing. It will handle the health checks, the retries. It will terminate TLS for you. So the internal traffic past the ALB is, probably visible by the cloud unless you're careful. And it provides other useful functions, like it will support sticky sessions. You can just do away with it. So what do we do under confidential computing? Well, first notice that commands to, this thing are sensitive on many different ways. Like, for instance, I don't necessarily want to have these commands misordered because I may end up, putting one strategy in front of another strategy, and that can cause real big losses. So you need to make sure that they're properly ordered, that there is confirmation of receipt of every command, because, again, you do not trust the middleware. So either you have a completely confidential ALB and you insert that, and then you need to govern it. It's not a trivial replacement. Or you'll need to sanitize and strengthen your requests. Like, even the request line in an HTTP request can leak information. Also, the headers of your HTTP request can leak information. And maybe a header can be dropped by an LB, or maybe another header can be added. Or maybe you go to the NLB. That probably comes with its own, bag of words. So again, in my paper, I provide some recommendations for what to do there. The key point I want you to carry out of this talk is you will not be able to just lift and shift, because you have to worry about how you're going to sanitize that entire flow of commands into your command and control service. So the command and control service today will be very similar to the ingestion service, right? It will probably rely on the identity and access management for your access checks, and then it will decide who can submit commands. If we don't trust IAM, that's a problem in its own right. So on the confidential computing, we need to figure out how this thing is going to work with the ALB. Right, I already said how. Maybe the ALB needs to be a network load balancer so you can proxy TLS. Then you can't really do sticky sessions. Maybe you change how you package the request. Certainly, your request body needs to be encrypted and integrity checked. Your headers need to be, some headers are sensitive and they need to be integrity checked. And maybe some of the stuff needs to, again, your request line perhaps should not be so revealing of what it is you're trying to do. Right. Then, on the other end, you need to establish mutual trust with the HFT and be cognizant of the fact that either one of them can undergo an update, a live update at any point in time. So you may need to renegotiate your TLS sessions. You'll need to handle rolling updates, key management on both ends of that. And how do you not rely on cloud IAM? Maybe you bake into the command control service the public keys through configuration, the public keys of all entities that are allowed to interact with it, if you don't trust IAM, which I have no evidence that you can today. So now let's look at the HFT service, the high frequency trading service. In there, we have, today, it will be very similar to the ingestion and command control service. The code is either in the clear, or it can be decrypted in the compute instance and launched in the clear. So for instance, if you're running a confidential VM, you can probably do that. Again, I would be very, very careful about, what if you have a VTPM? Well, the VTPM state itself, its endorsement key, needs to be protected somehow. How is it protected? Ask your cloud vendor. You're probably not going to get a satisfying answer out of most cloud providers today. I just don't want to point fingers. So under confidential computing, your code is confidential even while in use. It doesn't mean it's encrypted. It just means it needs to only be decrypted inside a T. And then you now have what I would call a two-phase attest. So first, you need to attest the node to gain access to the code. And then once you load the code and know that that's the code you want, then you gain access to the data. And then you need to repeat that for the next new instance, where, again, you have some questions about how much is it going to cost you in terms of reliability and performance, and you'll need some sort of optimization that you need to engineer for at the platform level. You'll need to be very, very careful to validate and authenticate all inputs. Maybe you reach back to your ingestion service when you take in market data to make sure it's actually the latest market data and protect against rollback that way, because one of the fundamental problems with confidential computing is you don't know what time it is, and you do not know, you don't know if you've been rolled back in most cases. So talking to another service that you're talking, that gets your data may be one of the mitigations. But again, not straight lift and shift. You have to think about these attacks. All right, going back to that diagram. So everything I just sort of, went through at this breakneck speed, which again, I don't expect most of it to stick at this level, but I have a 30-page paper that I just published that, I encourage you to read. So what do we do at the open source and application code level? Well, some code will have to be written differently, and we'll need some reusable patterns to do that well. What are some of the changes that impact almost all confidential code? Attestation-dependent ingestion of all secrets, securely communicating with all counterparties, even during upgrades when keys roll over, validating integrity and authenticity of all the inputs, generating properly encrypted and authenticated output, avoiding exposing sensitive data inside logs. That's very, very important. By the way, when you generate data from inside a trusted execution environment, the recipient of the data is probably not there to consume it, and you cannot really take that relying party and get like a nonce from them to quote, because they're not even there. Like, you're generating these audits. At some point, auditor needs to know who to court martial, and they would need absolute proof that it was that particular entity, which means that your audits, the authenticity of the trust execution environment generating the audit will be ascertained at a later time. We probably need reusable libraries to deal with this problem. And I hear from folks in Veracruz project that they're submitted in Usenix paper to that effect. I also have a paper that describes how something like this can be achieved. It's not a trivial problem, especially if you want to do something with performance. Again, I will reiterate, do not expose sensitive data inside logs, because you do not know who is going to look inside of them. So you need to be very, very careful that there is end-to-end security for such data. You need to make sure that you deal with untrustworthy cloud IAM, again, ideally through patterns. So all of these basic functions can be done better with the help of reusable embedded open source libraries. The CI/CD pipeline, it can detect unsafe code and deployment patterns. It will have to provide different and additional inputs to orchestration to do its job properly. It's probably a bunch of changes that need to happen there. I'm not doing full analysis in this short talk. On the orchestration front, again, I'm very, very excited, having heard that there is existing work happening in this area already. When I was preparing this presentation, I did not know what other contributions were going to be made. I'm super excited when you to start having conversations with the vendors providing these solutions in the context of governance, because again, highly regulated institutions is where you're going to make most of your money from confidential computing. All right, so rolling updates, key provisioning, incorporating attestation into all trust decisions, making changes to attestation policy when updates are rolled out. All of that needs to be properly governed. Once your application is deployed, now for one, notice you did not just compile your code and run it. Like, all the vendors will say, oh, take your existing code and we'll run it confidentially for you. You're not going to have a well-governed solution. You're going to have a bunch of confidential nodes, and then you will be missing the glue between them to actually do a good job where you can have full and proper attribution for all the things you're doing. Right. So your deployed application is now running different code. It probably has a different internal topology. There is not going to be a lift and shift. That's a pipe dream. Performance probably will suffer. I'm very excited about the PCI SIG TCG group work that will actually overlay some encryption of the PCIe bus, because right now you basically, every confidential VM needs to do the equivalent of Windows BitLocker on itself by itself, stealing CPU time from the compute instance. And big improvements will be on the horizon once we have network and hardware offload to confidential peripherals. Now, the supporting services will be more numerous, and we will have additional requirements, both supporting services that turn confidential and supporting services like, your garden variety stores that do not. Um, and then there'll be more controls. The controls themselves will need governance, more auditing overall that will ensure continuous compliance with governance standards. So tall order. Last but not least, all users of cloud services today must agree to this thing called the shared responsibility model with each cloud provider that they use. And this is commonly understood to mean that the cloud operator is responsible for secure operation of the cloud infrastructure itself, while the customer is responsible for the security of their environment. And the confidential computing brings a set of additional considerations to this mix, as confidential computing implies that the cloud provider removes itself from the ability to peer inside the user's secret code and data. And guess what? That also means, the cloud computing provider removes itself from the ability to go and downgrade like firmware of your AMD SCV machine or the microcode of your SGX, and then use that to peer inside your stuff, right? So your attestation decisions are no longer independent of what your cloud provider has done. So it's kind of an uncharted territory. So, for instance, how do you know whether your cloud provider is keeping the confidential computing hardware up to date? What changes are made and when? Because that, again, that goes to ceremonies, that goes to enforcers, and then goes to attribution. And the confidential computing security normally relies on transparency, but how do you know if closed source confidential service is keeping its promises today? Like, we do not have actually a good answer to that question, because like some cloud providers, again, not pointing fingers here, but their approach to this is, we're good at this stuff, so you should just trust us. And that's okay. Like, if your customer wants to accept that risk, fine, but I do not know how that's going to actually work with upcoming governance frameworks once the regulators take a peek. So the SOC 2 certification standard is what we hold our providers to, but that's like a yearly certification. I predict we'll need to have a discussion, and there may have to be some changes to that. So in summary, let's see, what do I want to summarize? Now, I firmly believe, and this is why I'm in this job, that the confidential computing is both necessary and very, very promising. Confidential computing, I believe, don't shoot the messenger, is not ready for widespread public cloud adoption by regulated institutions, because I just scratched the surface of the mountain of work that is ahead of us. The good news is there is a really, really great increase in the velocity of this technology. So the progress made over the last year, the number of hardware manufacturers like ARM has announced CCA. There are some things I know under NDA that I itching to talk about but can't. But and even in this talk, if you compare this year's conference to last year's conference, the number of changes going in and the amount of thought going into it, it's very, very promising. And all of these problems, I believe, will be solved. We just need to articulate the problems correctly. My recommendation to the Confidential Computing Consortium would be to adopt both governance and orchestration as its areas of interest, because ultimately we need reusable solutions. We need patterns. Basically, like the vendors done an amazing job with service mesh, but we have 14 service meshes, and last I counted. So we need reusable patterns across all of this. So my team, the Flare team at JP Morgan, would like to cooperate with vendors on creating, validating these new patterns around cloud confidential computing. And again, an institution such as ours will probably be your best, most profitable customer, especially when regulators, sink their teeth into this stuff. All right. Now, I do not know. I haven't looked at the time. I do not know how much time I've taken, but sounds like it's 12:30, so I ran out of my 40 minutes. So this is my Q&A slide. Please email me your questions if you do, or contact me on LinkedIn. The Flare page link is given, and we are looking to grow our team. We're looking to very strong senior people at this point with proven records of creating great IP. So if you have good academic credentials, if you have lots of patents, and you want to work in this space, please talk to us. And we're looking, far and wide for the best talent to join us. So that's it for my talk. Thank you very much for tuning in.